Hi everyone. In this lecture, we will be concluding our unit on probability theory. If you recall, at the beginning of this unit, we started out wondering how there could be good arguments that are not deductively valid. Now, over the past few weeks, we have looked in detail at how probability theory works, which culminated in understanding how to use Bayes' theorem to think about conditional probabilities. And now that we have all those formal tools on the table, we can now give a precise answer to our initial question, which was, how can we make sense of good inductive reasoning? And that is precisely what we're going to do in this final lecture of the unit. And then next week, we will turn to our final and very short unit on decision theory. So in the first video, I'm going to be talking about inductive strength, which is how we can give a precise characterization of what it means for an argument to be good in the inductive or probabilistic sense. And then in the next video of this lecture, I will consolidate some of the topics from Monday's lecture, where we use Bayes' theorem with multiple conditions to make sense of how we can talk about inductive arguments with multiple premises. So let's begin with inductive strength. So to repeat the very important insight, which is guiding what we're doing right now, is that we motivated in this course the study of probability with the idea that there are many good arguments that are not deductively valid. And those deductively valid arguments were what we spent Unit 2 on, okay? But when we moved from Unit 2 to this unit, we were trying to figure out how there could be good arguments that were not deductively valid. And if you recall, and as I'll review in a second, we noted that some inductive arguments can be more or less good. So because probabilities come in degrees, that's why we thought that thinking about probabilities could help us understand how various arguments could be more or less good. So now that we have the tools from probability under our belt, we can ask precisely what it means to say that an argument is inductively strong or good in the inductive sense. Or another way of putting it is that we can get a precise grip on what is good inductive reasoning. Now here is the guiding intuition, which I mentioned at the very beginning of this unit, which is that an argument is inductively strong to the degree that the premise makes the conclusion probable. So how can we understand that with all that we've seen in this unit? So let's first look at a couple examples that we looked at the very beginning as well. So here is a piece of inductive reasoning. So suppose you're in a jury, say, on a trial where someone, Smith, is being convicted of murdering someone else named Jones. So Smith, in fact, has confessed to killing Jones. Furthermore, Dr. Zed has signed a statement to the effect that he saw Smith shoot Jones. Furthermore, a large number of witnesses heard Jones gasp with his dying breath, "Smith did it." So as a juror, you take all this evidence as the premises in your reasoning, and you conclude that Smith, in fact, did kill Jones. Now, this seems like a very good piece of reasoning, despite the fact that it's not deductively valid. This piece of reasoning is not deductively valid because you can imagine a possibility, even though it's incredibly far-fetched, nonetheless, you could imagine a logical possibility in which all of this evidence is true. Yet, nonetheless, Smith did not do it. That is to say that the truth of the evidence here as premises does not logically guarantee or logically entail the truth of the conclusion. So to imagine what one of these logical possibilities might be in which the premises are true and the conclusion is false Suppose, for instance, that Dr. Z has framed Smith. So that's why Dr. Z says that he saw Smith shoot Jones, because Dr. Z is trying to frame Smith. And furthermore, imagine that Dr. Z has incredible powers of manipulation. So, for instance, Dr. Z is like a Bond villain, and so Dr. Z manipulates Smith into thinking that he did it, and that's why Smith confesses. And furthermore, Dr. Z has manipulated Jones into thinking that Smith did it as well, and that's why Jones says so, etc. So, in that possibility, even though it's very far-fetched, it's still coherent, and it shows that it's possible for the premises to be true, and the conclusion is false. But nonetheless, this is still a very, very good piece of reasoning. In our ordinary life, we would not question this, concluding that Smith, in fact, did it, because all of the evidence really strongly points to the conclusion. It makes the conclusion extremely probable. And so this piece of reasoning, even though it's not deductively valid, still is good, and it's good inductive reasoning. So we want to know how we can understand how that is so using probability theory. Here's another piece of good inductive reasoning. Suppose you're a scientist and you're trying to figure out the color of ravens. And so all of the ravens you've observed so far, you've noticed have been black. And let's suppose you've observed a whole bunch of ravens, a ton. And so because every single raven you have observed so far has been black, what you conclude from that evidence is the theory that 100% or all ravens are black. Now, it seems like this is a very good piece of reasoning, and it's similar to the kind of reasoning that is done in empirical science. There's a whole bunch of observations which confirm a theory, and so we conclude that the theory is right based on those observations or those pieces of evidence. Now, of course, this argument, however, is not deductively valid. So just because every raven you have observed so far has been black, that does not deductively entail that all ravens are black, because there might be ravens that you haven't seen already, which are not black. All right? But despite that, this is not a logically valid argument. Nonetheless, it is incredibly good inductive reasoning. And so we want to understand how this is a good argument or a good piece of reasoning. Despite that, it's not deductively valid. And finally, to illustrate the point that inductive arguments can be more or less good, suppose I say, try to make the following argument. So I say, last winter in New Jersey, it was warm. Or suppose I say, the last 2 winters in New Jersey were warm. And then I conclude from that every future winter in New Jersey will also be warm. Now that has a very similar structure to the argument 2 here. However, this is not a very good argument. It's not a very good piece of probabilistic or inductive reasoning, okay? And so while A2 and A3 here, neither of them are deductively valid, nonetheless, A2 is better or more secure piece of reasoning than A3. So what this shows is that inductive reasoning can be more or less good. It comes in degrees. And because probabilities come in degrees, we will be able to explain that. So let's see how to explain that. Now here is the first proposal, and we're going to show a problem with it, but this is kind of very close to what probability theory can tell us about inductive reasoning. So our first and simple proposal is that an argument with premise phi and conclusion psi, so these 3 dots just mean therefore. They're just short for the therefore. So an argument phi, therefore psi, is inductively strong to the degree that the probability of the conclusion given the premise approaches 1. So 1, as we know from probability theory, is the highest probability something can have. So the closer that conditioning on the premise makes the conclusion's probability close to 1, it makes it the better argument, increases the strength. So what we can say is that an argument is strong to the degree that the conclusion is probable, given the premise. So here, for instance, the premise that all of these ravens you have observed are black makes it very, very probable that all ravens are black. And similarly, all of this evidence about Smith, though it doesn't entail that Smith did it, makes it very, very probable that Smith did it. And so that's why these are very strong arguments, inductively speaking, because they're strong to a very high degree, whereas the fact that there were 1 or 2 winters recently that were warm does not make it very likely that every future winter will be warm. Equivalently, what this proposal says is that an argument phi, therefore psi, is strong to the degree that the negation of the conclusion, given the premise, approaches 0. So the premise makes the negation of the conclusion very unlikely. That's another way of putting this proposal. And so to understand this proposal in a bit more detail, we can think about it geometrically using the diagram which we used to talk about conditional probability when we introduced it a couple weeks ago. So when we're asking about the probability of A given B, in this case A is the conclusion and B is the premise, what we're asking about is how much of B's space does A also take up? So that is to say that if we suppose B is true, if we condition on B, how much of the remaining space within B is also A space? And the more space within B, that A takes up, the higher the probability of A given B. So that is to say that the bigger this purple area is, the more of B that this purple area takes up, the more probable that A is given B. And in this case, B is the premise, so we assume the premise is true, so we assume that we only care about the space within B. And then, assuming that's true, we wonder about how much of that space does A take up, and that is, and the more space that A takes up, the more the probability of A given B approaches 1, and so the more the premise supports the conclusion. But however, here's a problem for this proposal, so we're going to look at this problem and then give a slight amendment to this proposal, and that will be our official account of inductive strength. So I want you to consider the following argument. Fred Fox, who is a man, is on birth control pills. That's the premise, okay? So we find out that this man is on birth control pills, and we argue from that premise that Fred Fox will not get pregnant. So this should strike you as somewhat strange of an argument, and here is why. In this argument, the probability of the conclusion given the premise is extremely high. So for any man, so for Fred Fox, given that he's taking birth control pills, it is extremely probable that he will not get pregnant. Okay, so according to our proposal, the conditional probability of the conclusion given the premise is very, very close to 1. So according to our proposal, this should be a very, very strong argument. However, there's something strange here because it doesn't seem like the premise really adds something. It really adds much probability to the conclusion. That is, the probability of the conclusion is already very high, regardless of the premise, because Fred Fox, regardless of whether he's taking birth control pills, will most likely not get pregnant because he's a man. So just because the probability of the conclusion given the premise is very high, it might be that that is in part because, or mostly because, the probability of the conclusion is already very high. So it could be that the probability of the conclusion given the premise is very high, but it's not the case that it's a premise which makes the conclusion be very probable. So that's why this argument doesn't seem like a very good piece of reasoning, even though our first proposal does. Now, relatedly, and the moral is that the premise kind of seems irrelevant to the high probability of the conclusion. So it doesn't seem like a very good argument. Now, relatedly, to generate some more counterexamples to the proposal, you can reflect on the following question about take any other argument and, regardless of what the premise is, make the conclusion be a logical truth. So for instance, it will either rain or it won't rain, okay? And for any argument with a conclusion, which is a logical truth, regardless of the premise, you can ask about how high the probability of the conclusion given the premises, and the answer is that it will be very high. But there will be cases in which it nonetheless doesn't seem like a very good argument. And so that is something that you can work through to find other problems with our proposal here. So here's what we're going to do to make this proposal better. And here's our final proposal. An argument, phi therefore psi, is strong to the degree that first, the probability of psi given phi approaches 1. So this was our first proposal. But we add that, in addition, we need to think about the degree to which the probability of psi given phi exceeds the unconditional probability of psi, the conclusion. So in this case, the conclusion already had a very, very high probability. The probability of C was already very high. So the second condition won't be met because learning the premise doesn't increase the probability really that the premise already has. So in addition to the conditional probability of the conclusion given the premise being close to 1, we also need it to be the case that the probability of the conclusion given the premise exceeds what the unconditional probability of the conclusion was. So here we simply add this second proposal, the second condition, to our first proposal. And we require that, in addition to the probability of the conclusion conditional on the premise being high, that conditional probability must also exceed the unconditional probability of the conclusion. And this proposal gives a formal characterization of the following insight, which we began this unit with, which was that an argument is strong or inductively strong to the degree that the premise makes its conclusion probable. And here we have a formal characterization of what it means for a premise to make a conclusion probable. So in the next video of this lecture, we're going to be addressing the following question, which is that these proposals seem to be only considering arguments with a single premise, phi. But of course, we can construct arguments with multiple premises. So in the second video of this lecture, I'll be talking about how to apply this proposal to think about inductive arguments with multiple premises.